Okay, part 2 of the mole conversions. I'm going to do one more example of just a one-step, and then I'll go through a two-step one with you. So example 7, again, we're still in our, under unit 2, the section that is formula, mass, and the mole concept. If you're in that section and you scroll down to example 7, this is what we're looking at. I did modify it a bit just because there is additional concept that I wanted to throw in here. So you'll see it does look slightly different than what's in the textbook. So I have 0.443 moles of calcium phosphate, and I want to know what the mass is of that. So I'm going to be going from moles to grams. Since they're right next to each other on this chart, I can do that in one step. Now, before I do this, I need to figure out what the formula is for calcium phosphate, and this is where it's super important that you have taken the time to really learn those naming rules. It is going to take a while, it is cumbersome, it's probably going to involve a lot of reviewing of videos and watching various lectures and doing practice problems, but this is going to stick around all semester, and it is going to be something that's going to get really tough if you have to pause and take a really long time to figure out what a formula is before you can even do a problem. So you're going to start to see that here. Really important, the time investment that you put into learning how to do the naming and formula writing is going to pay off tremendously and is going to save you a substantial amount of time going forward in the semester, especially whenever you're going to have tests and you're going to be very limited on your time. And if you're spending, a lot of time trying to search and figure out how to do naming, you're going to be in trouble. So just my little piece of advice to you. So calcium is Ca, phosphate, I see that ending with the T. That indicates to me that this is a polyatomic ion, so you should go to that chart, that table in your textbook. If you look up phosphate, you'll find that it's PO4. The charges is what I do next for ionic. So calcium is in group 2, so it's a +2. If you look up phosphate on your chart, it's a -3. Those two, in order to get them to balance out, I need a least common multiple of 6. So the 2 needs multiplied by a 3, and the 3 needs multiplied by a 2. In order to multiply a polyatomic ion, you have to put parentheses. So that's going to be my final formula. So now I can go ahead and jump into this problem. I have 0.443 moles of the calcium phosphate. Okay, and I want to go from moles to grams. We established that can be done in one step. Since moles is on top, I'm going to put moles on the bottom. And grams goes on top. That's what I'm converting to. Okay, and according to my chart here, I can, wherever mole is, I can put my 1. And where grams is, I have to add that up on the periodic table. So this one I am going to break apart because I didn't really see a parenthesis example in the text. So I'm just going to quickly just go through with you. So if we were adding up the molar mass of this one, we have our 3 parts to it, the 3 elements we have to find. I have 3 calciums. I have, in this case, the 2 gets distributed to what's inside the parentheses. So 2 times 1 means that this particular compound has 2 phosphorus. And then lastly for the oxygen, again, this 2 distributes to just what's inside the parentheses. When you distribute, you multiply. So that tells me that I have 8 oxygens. Right, and then I can go ahead and multiply the number of atoms I have by the mass that I find on the periodic table. Again, at this point, it's just like the examples in your textbook. They did lots of them that you can then go ahead and do. So you can find the little answers between each of these. And then you get this. And if you add all of those up, you should get a total mass, molar mass, for calcium phosphate of 310.18. But that's the biggest thing I wanted to show you is when you have parentheses, this subscript acts as a distributor to everything inside. It doesn't work outside, just to what's inside the parentheses. So at this point, we can go ahead and solve. We need to solve to 3 sig figs. And if you round your final answer to 3 sig figs, you should get 137 grams. Okay. So we're going to end with an example that just I came up with, and it's going to be kind of the putting all of this together, a little bit of what we did in Unit 1 with basic conversions and then mole conversions into one question. So what we're gonna, and there's also some formula writing in this question too. So about 3 different concepts are coming together in this question. So it asks, what is the mass, and I added in kilograms, of 6.78 times 10 to the 25th formula units of magnesium phosphide. Again, I'm given formula units and I'm asked to go to the mass. Now for this one, we're given formula units, which is in this box, and I'm asked to go to grams, which is in this box. This is an example of something that would require a 2-step to get from formula units to moles, and then from moles to grams. You always have to go through the mole. I can't jump. These two are not equal to each other. There's going to be some extra things we're going to throw in later in this chapter that's going to give you a massive headache if you try to just jump from one to another. So get in that habit. If you see one is here and one is here, do those 2 separate steps. And like I said, you'll see why that will help you tremendously if you get in that habit now. So we're going to go ahead, start. Before we do that, we're given a name. We need to put that into a formula in case we need to calculate mass for this problem. Magnesium is going to be Mg. Phosphide, that ending of IDE tells me it came from just the element phosphorus. So I can look at my charges on the periodic table. Again, least common multiple is 6. The 2 needs multiplied by a 3. The 3 needs multiplied by a 2. So that's my first step, is to get that formula. All right, then I'm going to take my 6.78, what I'm given, times 10 to the 25th formula units of Mg3P2. There's like a super, I am very limited on the width that I have. You would probably want to write it all out in one long line, but you would never see this if I tried to. I'd never get it on this vertical piece of paper. Okay, so my first step, I'm in formula units. My first conversion is going to be to moles, so that's what I'm going to set up first. Formula units is on the top, so I'm going to put my unit of formula units on the bottom. And my first conversion has to be to moles. You're going to see that I'm going to keep writing the compound out. Again, this might seem like an extra step. That's not necessary, but what we're going to do in the next part of this chapter, you're really going to want to make sure that you get in that habit of writing out the compound, because we're going to see that compound start to change. And if you're not continuously writing it, you're going to get super confused on what it is you're talking about. All right, so back to that conversion chart. Wherever I see moles, I'm going to put a 1. So moles is on top. That's where my 1 goes. Wherever I see formula units, that's where I'm going to put the 6.022 times 10 to the 23rd. And I have to keep going because the problem doesn't ask for moles, it asks for mass. Okay, so my next step, moles is on top. I'm going to put moles on the bottom and grams on top. If we go through and we find the total mass of that, Mg3P2, you are going to find that it is 134.87, and that's to 1 mole. Okay, I'm going to have one additional step because I asked you to go to kilograms. This is our revisit of Unit 1. Grams is on top. I'm going to put grams on the bottom. and I'm converting to kilograms. And we should recall that there's 1,000 grams in 1 kilogram. So this problem will culminate if I multiply across the top, divide by the bottom, round my final answer to 3 sig figs. We're going to have 15.2 kilograms of Mg3P2. So hopefully this example of showing you a two-step problem will help you kind of moving forward with these.